The energy transition. What does it mean? And what is the impact on our electricity infrastructure? Energy transition simply means that we want to move from the fossil-based generation of electricity to a more renewable one, using wind, solar, and also from hydro. It's good to understand the way the electricity network is designed. The original idea of the electricity network was to take energy that is produced by big power plants far away from consumers, to take those energy, bring them to the consumers. It was very simple because it was always taking the energy from one place to the other in one direction. Consumers didn't need to do anything than to consume energy. Producers only produced what consumers needed. And the transport capacity was enough because we knew what was going to happen almost in advance. Now, energy transition comes in. We need to move away from the fossil base to more renewable. These renewables are dependent on nature, sun and wind. And because the sun is not always shining and the wind is not always blowing, fluctuations between the demand and the supply is increasing. A time comes, there's so much production, so much that the capacity of your electricity grid is reached that you cannot transport them. This creates what we call congestion in the network, not only at the production side, but also at the customer side. The customer was made to understand he can only consume energy. But with the energy transition, customers have moved to also produce energy. Think about the street, having houses with electricity, with solar panels. This means that these customers can also produce electricity. And when they are not at home, such electricity can flow back to the grid. And this also creates a challenge for the electricity network, moving from one direction to bi-directional flow of power. Another problem is that we see the society increasingly using more electricity. Mobility becoming more electric. Also, some homes are using electricity for heating. This increase in electricity also ensures that the customer side demands more and more energy. This affects how much we can transport to the customer. With variations in the production side and the increasing demand at the customer side, the electricity grid has to also be transformed to handle these changes. How can that be done? Which means that we need to look at the solution from the production side and the grid itself and the customer side. This is what we term as flexibility. How can we ensure this is done? From the customer side, it means that local storages could be helpful so that when the customers are not there, such energy could be stored to minimize the flow of power to the grid. On the grid side, reinforcement may be necessary, but this takes time. So smart designs and controls will be necessary there. On the production side, when it's large-scale production of wind and sun, we need a form of storage to go with these sources to minimize overproduction or underproduction, as the case may be. These could help us that the electricity network can still operate and function as we transition in the energy system.